Hello and welcome to this webinar on testosterone and DNA. We're just going to give it a couple of minutes to allow other people to join. But if you're already part of the webinar, then feel free to use the chat function, and you'll be able to participate in the event. And if you could just drop your name and also your company as well, that would be really useful, just so we know who we've got with us. Olats, first in, as expected. Welcome. We'll just give it a couple more minutes to allow other people to join as well. Whereabouts are you today, Olats? London, excellent. Okay, we'll just give it a couple more minutes. We'll get started at sort of 2 minutes past. Anyone else, as you join, do feel free to use the chat and just let us know where you're joining from. Courtney, Ohio. Welcome. Good to see you. Ohio, Moxie. And Courtney, I believe you're an existing FitnessGenes member, right? How long have you had your results for? Since 2017, great. Long time member. That's good to see. Josh is calling with a question. Josh, I'm not going to accept that right now, if that's okay, just so we can get started. But Josh, good to see you join us as well. I think we'll get going, and if more people join, then that's great. But the chat function is open and available, so if people do have questions as we're going through the content, then please do feel free to drop them in there, and we'll pick them up as we go through, or we'll review those at the end and put those to Stuart. This webinar today, it's very much focused on our most recent report that we've released. So last week we actually released 2 reports. So we released SHBG and bioavailable testosterone, as well as endometriosis as well. So the testosterone went out to male members and the endometriosis went out to female members. But today we're going to focus on that testosterone trait and discuss actually sort of like the science behind it, use this as an example to showcase how we actually construct our reports and pull together our recommendations, and then also discuss how that information can be used within a clinical setting as well. So as usual, I'm joined by FitnessGenes co-founder, Dr. Stuart Grice, who's also our Chief Scientific Officer as well. So welcome, Stuart.
Thank you.
Now, I know, so people like Josh, for example, are people that we've met quite recently, so I don't believe they've probably had the pleasure of meeting you previously. So would you mind just giving a quick introduction as to your background and also your role at FitnessGenes?
Sure. Generally, as a scientist, they keep me in a cupboard and roll me out very rarely. But sure, yeah, I'm one of the co-founders, been part of FitnessGenes for the entirety of its existence. I'm an academic by background, did my doctorate at Oxford on neurodegeneration, and then more broadened out to looking at metabolism, disease genomics. I left Oxford as my position as an academic in 2017 to come full-time into FitnessGenes, where with the science team we build a lot of the scientific models, manage the bioinformatics pipelines, and build a lot of the traits you see coming out on a regular basis.
Excellent. So yeah, just on those sort of regular trait releases as well, I think for the benefit of sort of new joiners, it's probably ideal to give a bit of a background on the company. But people like Courtney, you'll be fully aware of this. But we've been researching and delivering genetic reports on a pretty regular basis since March 2019. We were just discussing with Stu. So quite recently, we're doing it every 2 weeks and kind of reviewing that for 2025. But that means people like Courtney, you would have received over 135-ish reports in that time period. We've been in this process as a team of pushing forward sort of genetics research and being able to provide those reports to members. But I was just saying, we've perhaps been slightly modest in terms of our scientific credibility. So as part of our strategy as a company moving forward into next year is to look to produce more sort of content around the research, and live webinars like this are a great opportunity to do that. So this is the first of hopefully a few moving into the new year. So any feedback that people have on the format and the information providing would be very welcome at this point. But yeah, I think that's time to get into the subject. We're at 5 past. So as I say, SHBG and testosterone was released last week. So that went out to all of our members, but also went out to all of our B2B partners as well. So that report is now available for anyone who has FitnessGenes results. And later on in the webinar, we'll actually walk through how to access that report. But Stu, I mean, my understanding before reading this report was that, testosterone has a pretty prominent role in health and performance, especially within males. And the idea is to maximize testosterone availability to sort of make the most of its advantages. But having read the report and the relationship, especially between SHBG and testosterone, it seems a lot more nuanced than that. So if you wouldn't mind, just let's start right from the very top. Kind of what is testosterone and actually what does it do?
Sure. Yeah. So, testosterone is classically known as the male sex hormone, but both males and females produce it. Obviously, females in a lot lower levels and from the adrenal glands. The trait we built this time was specifically male because at FitnessGenes we build models to obviously identify different levels of things and also the associated risks. Now, the way that male and female systems work is they're innately very different, and also the variants associated with it have different effects. So at this stage we built a male model, and we'll build out a female model, particularly then looking at how that impacts conditions such as like PCOS, where higher levels of testosterone in females are linked to PCOS, polycystic ovary syndrome. So just kind of back to the male model we look at in a minute, it's very much around predicting levels, but on 3 sort of separate components. That is the total level of testosterone, how it then relates to its binding globulins, and then also something called free testosterone. So little backtrack, why is testosterone important? So males, it's important for developing the secondary sexual characteristics, so sort of hair, deep voice, etc., production of gametes. But I guess probably more for this market, it's sperm and red blood cell production, libido, and then muscle maintenance, body mass, lean body mass, and bone density. So kind of attributes that people are looking to improve in the gym, but also in terms of long-term health. Muscle mass and lean body mass are really important for mitigating many chronic diseases. So as I touched on before, and you kind of highlighted that, classically we think of testosterone. The more testosterone, you're stronger, the bigger, the healthier you are. But actually testosterone, the majority of testosterone in your body is actually bound to proteins. I think about 50-60% of it's bound to albumin, and this is loosely weakly bound. And then about 30-40 to 50%, depending on the person, is bound to something called sex hormone binding globulin, or SHBG. And that's bound quite tightly. Now you have a few percent left, which is called free testosterone, and this is what actually acts within the cell and will drive the growth pathways that will drive muscle growth and everything else. So actually it's this free testosterone that's really important. So actually we can have, in theory, high levels of total testosterone, so you can do a blood test and measure total testosterone, but that individual can have very low levels or lower than average levels of free testosterone, and that can not be good. So we need to really understand how we can predict what free testosterone levels are. Are there factors that impact it? And how can then genetics make better predictions around that level? And how does this interact with blood data? Now, the one thing we'll go through in a minute is how can we use the genetics to make a better prediction in someone, whether they're going to be susceptible to reduced testosterone, particularly free testosterone, in the long term, and actually whether when you do a blood test, you measure their testosterone levels, is it actually okay, or is it something we should be concerned about?
Okay. So, I mean, it seems like the ideal kind of result here is having high free testosterone as a result of having high total testosterone, but also lower levels of SHBG because more is therefore available as it's not bound to SHBG. So is that the case?
In general, yes. So let me just get a little graph. So this is actually going to be a graph of a small subsets of our client base. Now, can you see this picture here?
Yeah.
Yeah, is it reasonably legible? So what you have here, this is kind of within our internal system. So what you got here is the numbers are individual people, and you can see on the x-axis you've got a test score. So this is total testosterone, which increases. Then you've got a sex hormone binding globulin score along the y-axis, where you've got high levels and then decreasing levels. Now the frequency heat map is just how many people generally fit within these. So when you get a band in your trait at FitnessGenes, you'll be bucketed into these different components. But what you can generally see here is the trend of the higher generally SHBG you have, the higher test score you have. And that makes sense biologically, that generally when you have increased testosterone levels, you have an increase in sex hormone binding globulin. They're basically, so on your point of you want higher levels of testosterone, lower levels of SHBG, you're correct. However, there's a feedback loop within the system that generally when one goes up, the other goes up. We'll talk about other moments when that doesn't happen in a minute. But you're right, what you want to do is have enough testosterone in the system and enough SHBG, but not enough to totally sequester all the free testosterone, so you have an active pool there. But as you can see, this is an upward trend, but you can see there's variation with customers. So there's people who have the same test score, but differing amounts of sex hormone binding globulin. So if you think about, you've got that number 25 point there, that's someone that has a high test score, so they potentially would be scoring very high on total testosterone, and that's something that people will go, okay, well that's very positive, but they've got a very high SHBG score. Now when you build that into the models that we have in the traits, so I'm just going into this graph, now we're looking at scores of SHBG and plotting it against the free test score. Now as you can see with that person number 25, they unfortunately are in the lower test score. So actually taking this information into account, you're starting to plot people to understand actually what their risk is of having higher or lower free test, which actually mechanistically is more important. Now there's a second component to this, which is a subset of the bands that we call people bands. So we put them into buckets, and they will get personalized information describing their genetic context. That actually some of the genetic variants impact the binding kinetics of testosterone to SHBG. So if you were to get a blood test, you get an SHBG score, a free test score, and then they'll try and calculate an overall free test score from that. However, there are some people that have tighter binding of testosterone to SHBG, and some people that have a looser binding. Now, if you have a looser binding, that actually improves your free test score, because actually you've got more transient movement of bound to unbound testosterone. So this, in combination, you can actually use this to predict what the risk someone will have lower free test, or is someone more likely to have a higher free test level. Now, just a kind of final point on this as well is, that blood testing is, we know there's a large variation. You could see from the first slide, there's a large variation within the normal the normal level of what testosterone should be. If you actually have you test your testosterone levels and SHBG levels at particular companies, they'll actually give you different thresholds for what is good and bad. So there's no defined good or bad within a broad range, and then of course there's very high and very low where they move into the clinical ranges. Now, if you just take 4 people for example, and say you test them at the age of 45, and you may have someone who has, I think, 15 nanomoles per litre, someone 20, someone 25, and someone 30. So you could argue that the 15 nanomole per litre person is at most risk. Now, actually, it might be the 25 nanomole person a year ago was actually 40 nanomole per litre. So actually, over the last 10 years, they've had a big decrease. That is more problematic than just actually staying moderately low and consistently staying moderately low. So our genetics can actually also enable us to interpret where our kind of Goldilocks zone is, what is looking normal to us, because genetically we do have this broad variation. Unless you're getting a test, and I don't think there's many people that have had a testosterone test in their 20s. There will be some people, but again, it might be for clinical reasons. So actually understanding your baseline and then interpreting the blood data against that baseline is really important. So the genetics, so in a nutshell, the genetics can help you understand what really your baseline should look like. So it can help you interpret your blood data better if you have blood data. But it also can come up with better free test predictions, because actually you're taking information about the binding kinetics of testosterone to the binding globulin itself. So there's two sort of layers of advantage on there.
So yeah, so it sounds like just getting a picture of someone's total testosterone isn't presenting enough of the full picture, and then also just understanding the relative relationship between SHBG and testosterone also potentially isn't enough, because it's not taking into account how testosterone may disassociate from SHBG based on sort of the way that they're joined together. Is that correct?
That's correct, yes.
Okay. So this sort of population distribution is quite interesting, and could we use this to kind of dig into how FitnessGenes members are split between different bands and the variety that we're seeing within our membership, and how we use that to deliver the insights and recommendations?
Sure. So as you can see, there's a plot here, and obviously there's two graphs. So you've got two pieces of information. You've got your SHBG versus total test, and then you've got your prediction of the free test. I've also described this binding kinetics information that goes in. So what this then, it buckets people into different layers of criteria, that you're higher, middle, lower, higher, middle, lower on free test, and then have different binding kinetics information. This will then put you in a class or a bucket, and at the moment I think there's 45 in this trait. So that's the layer of granularity, and then that information will describe, you know, whether you've got higher or lower levels of testosterone, SHBG, whether that then impacts your free testosterone if free testosterone is an issue, and also the binding kinetic stuff. There's a second layer we're building in at the moment. So in the direct consumer part, this exists already, and this has been built into the B2B part, which is about the lifestyle data. So the lifestyle data will then modify. So just to go to a third, excuse me, let me find my presentation. Where are you? There you go. So there we go. Is that changed over? Sorry. Yeah, cool. So this is, so what we've done as well is, along with having a DNA-based model, we also have a lifestyle-based model. So what you've got here is, so there are more factors than just age and BMI, but these are kind of nice examples of generally. So you've got testosterone with age, testosterone with BMI. BMI, I know it's not perfect, but we test our sort of models and body composition models within the system to kind of make them as accurate as possible. But as you can see, you've got with age, you've got this cross point of 70 where testosterone levels dip under sort of the average required, and then SHBGs go above it. So you can see at that age of 70, you've very much got a shrinking amount, the shrinking pool of the free testosterone. Now with overweight people, the BMI is around 27, where you have that both decrease in testosterone, but you also get a decrease in SHBG. And I think this is specifically to do with fat buildup in the liver. So I think specifically with obesity, it seems to be visceral fat and fat in the liver that actually increases the risk of hypogonadism, so reduction in testosterone. So we've actually built these components of the model in also. So we have smoking in there, alcohol use. The one thing we didn't put in, but actually was surprising in one of the papers, was actually whether you're married or not. So married people generally have a lower levels of testosterone, and there's probably a social child rearing interaction here. There's probably an evolutionary advantage to this. But we haven't got that quite in the model just yet. But we build this lifestyle model on the side. We have our genetic model, and this enables us then to make really good long-term predictions for people's potential risk of a dwindling testosterone. And again, just taking into consideration those variables. Yeah,
I'm just trying to work out who this information is most critical for. And if I've understood correctly, it would be those where they have genetic variants associated with lower total testosterone, higher SHBG, but also lifestyle factors such as being overweight, sedentary, and of older age as well? Are those the people that are kind of at that highest risk in terms of those 45 different potential outcomes?
So I would look at these two ways. First, there will be people that want to maximize muscle mass. So there may be people that know they've got naturally lower levels of testosterone total, and have average free testosterone. They can look at strategies of driving testosterone, and most of the strategies will be driving total testosterone off. But when you're increasing that pool, when you do acute like exercise, strongly acute high interval training, that sort of stuff, you can drive, you can increase your free T pool transiently to drive muscle mass. So there's that group of individuals that actually, when you're thinking about maximizing muscle growth, you're going to be looking at your insulin function. You're going to be looking at alpha-actinin 3 and the proteins associated with recovery. You're going to be looking at IGF, growth hormone, but also you're going to be looking at testosterone. So if you're really looking to maximize muscle mass, this information is important. But the secondary component to that is, you're absolutely right. You kind of find this with all growth factors. You have this Goldilocks zone. So if you have lower pools of low pools of free testosterone, you're going to be more prone to reduce muscle mass, reduce bone density, and also chronic conditions, metabolic conditions, so obesity, diabetes, you can have an increase in risk. Now, put the flip side of that is if you have actually naturally very high levels of testosterone. Now, there's more to this story than just testosterone, but if you were to have high levels of IGF-1 and naturally high levels of testosterone, they're very beneficial for growth, but they can also increase your risk of, as a man, prostate cancer. And actually, you see the genetic variants associated with higher levels of testosterone and the genetic variants of higher levels of IGF-1, which have been shown to be beneficial for strength and everything else, are also increasing the risks that are associated with 2-3-fold increased risk of prostate cancer. So again, if you have these variants, you may actually start to think about, okay, well, I'm 45 now, maybe it's time to, do I have a family history? No, but do I have this increased risk of these levels? Well, actually, let's potentially look for screening. So again, this is building into the personalized medicine sort of repertoire of how because medicine's driven by economics as much as science, and if you know which tests to do at the right time, you can start to really start thinking, actually, I'm going to take a prostate cancer test 5 years earlier. The second point, when we talked, you were about to say something, Alex.
Yeah, no, I mean, we're jumping ahead slightly because that was one of my questions, was like,
okay,
actually, how can we use this as a tool within a clinical setting or, within a professional setting and you're giving the example of prostate testing, but how can we use this as a tool within sort of wider health screening? I know a lot of people in the audience will be people who are looking to use this with clients. Yeah. So how is this something that they could use to sort of, make sure they're catching these risk factors earlier?
Sure. So another example is when we talked about the delta. Say for someone, you've got like 4 people, they come into your clinic, you've got someone with 15, someone with 20, someone with 25, someone with 30. And okay, they're all within the normal range, but actually the person with 15 actually has a high genetic testosterone score, but a low blood score. That sort of disconnect actually, to me, would actually, if that was me, I would go, okay, well, actually, I want to probably do another testosterone test in 6 months' time, because there seems to be, actually, naturally, I should have higher levels, but I've got lower levels at the moment. And then if I was to then see a drop again, then there's a significant action I'd probably want to take. Now, if someone's got moderate genetic levels and they're testing with moderate amounts of testosterone, that kind of makes sense. Again, people sit within this broad range, and just because you've got moderate to moderately low levels, that doesn't necessarily mean it's not healthy, particularly if you then start looking at the fact that actually you've got a reasonably good free T pool. So it's a way of actually then going, okay, well, I think I'm happy with testosterone levels at the moment, but actually maybe I may want to look at sort of other components of my health, or actually, because of this disconnect between my genetic levels versus actually what I'm seeing, this potentially shows me that I'm actually maybe decreasing below what is naturally my baseline or naturally my normal Goldilocks zone, and I'll take a lot more take a more of a look at my testosterone levels, and that will include multiple tests, maybe even 2 or 3 in a year. Is that kind of the sort of perspective.
And I guess the progression from that, from a sort of a practitioner point of view, is as well as providing that health screening and assessment, is then what are the kind of the practical takeaways or the recommendations that they can then provide to clients if they find that someone does have a low pool of bioavailable testosterone. What are kind of the exercise, the nutrition, the supplement recommendations that we're able to kind of provide?
Sure, yeah, and again, it depends because obviously there's different recommendations for the different 45 buckets. But if you're, so if you're someone that's maybe overweight, so things like there's something like fenugreek, for example. Like there's been multiple studies on fenugreek. Some so it doesn't raise testosterone in men, some it does, and that's because actually it raises testosterone in slightly overweight, aging men, but it doesn't raise testosterone in healthy men. So there's an example of where you can actually give a differential recommendation for certain people. That there's the core: sleep, exercise, high intensity exercise. There's a suggestion with good fats. Now I try to pick this out a bit because I was expecting to see vegan diet, low testosterone, but actually it doesn't seem to tease out in the data. And that's because I was expecting good levels of cholesterol in the diet, everything else, and also SHBG is production is very much modified by monosaccharide and also palmitates, so basically metabolites of fat. So different fats can have small impacts on your testosterone levels, but generally, if you're striving to have good muscle mass and you're lean, then that's the most important thing, really. There's obviously, if you've got lower levels, depends what country you're in, but DHEA is something that's been shown to actually raise levels. Actually, it's also been shown potentially to lower slightly in certain people SHBG levels, so that actually potentially can free up the free testosterone pool. Zinc, magnesium, boron, really important if you're not getting enough of that, and especially if you're training quite hard, you might have to look at those micronutrients because they're really important both for the action and the production of your hormones as well. So because obviously we've got the environmental component as well. So for some people, we'll be recommending things to sensitize people to insulin because that's really important. Like people, sort of pre-diabetics and diabetics have a significantly lower level of testosterone. So it's really important to make sure you're insulin sensitive. There will be other components, and now these will feed into other traits that we're building down the line. As you mentioned, we release new traits, but the risk of non-alcoholic fatty liver disease. Now, some people are more prone to both visceral fat buildup and also buildup of fat in the liver, and that's something that should be modified. So if you've got family history, and in the future we'll look at the genetic component of that, that's something that should be targeted. And also then sort of any low grade inflammation. So even if you are physically healthy, but you think you've got some, the autoimmune issues, you've got inflammatory processes going on in your body. Again, body fat is your prime example, and diabetes where you have chronic inflammation. Factors that reduce inflammation are really important for making sure you maintain both a good total amount of testosterone, but also a good free pool of testosterone as well.
Okay, great. So just as a bit of a summary, then I guess, this is information that's essentially relevant and important for any clients in terms of assessing their long-term health risks. But those people where they're coming back with results where they've got a low pool of free testosterone and higher levels of SHBG and also lifestyle variables that can impact free testosterone, those are the ones that really have to consider the actions they take. Sure. Those actions are very much the classics that we've looked at in terms of maintaining proper body composition, sleep, but also some supplementation that you've mentioned as well. And I think it was quite interesting sort of hearing you talk about how the genetic testing and the genetic component provides insight that can't be obtained from blood testing, but it can be used as a way of signposting people to testing. Especially if they're at that higher risk, so that they can understand their absolute sort of like result on an ongoing basis and monitor that as well. So hopefully that's kind of a summary of everything that we talked about. Anything else that you'd add into that?
Yeah, I think just touch on the blood testing as well, because blood testing is very good, but there are many grades of, like the Lancet blood testing is not going to give you that accurate result. So if you're really concerned about your hormone health, you should have, intravenous extraction, and you should very, very specifically look at the whole hormone profile. So that, but then if you want to, you want to know your IGF levels, your growth hormone, your insulin function, all of a sudden that becomes very expensive. So the genetics really is very good at signposting what the tests you should be doing, as well as we mentioned about the binding kinetics, putting bits of information there that the blood testing cannot offer you. And this is not just within testosterone. We see this more broadly in understanding mTOR, IGF-1, particularly facets of insulin sensitivity and signaling as well. So it's about piecing together that information. And biology, we talk about this in our podcast as well. Biology again is not about high levels or low levels. Actually, you've got this flux and interplay between transient states. Like testosterone cycles very much through the day. It interacts with cortisol. You'll have high levels in the morning and the evening. After a meal, your testosterone levels will change. So it's really about getting a sort of a solid foundation to understand what your levels should look like, and also what risks you may have potentially in the future based on those levels. Correct. So I think that's a bit long-winded way of saying what you said was correct.
Yeah, we'll clip that up. That'll be fine. Do you mind if I get you to stop sharing your screen, actually? Because what I wanted to do was, I forgot we were sharing that. But also just show people where they can actually find this report, because, as I say, this report has been available from last week. So everyone who's received their FitnessGenes results will now have access to SHBG and bioavailable testosterone. So what I'm going to do is I'm going to share my screen just to show where people can find this within the portal. So hopefully you can see that now, Stuart.
Yes, I can.
Yeah, so these are my personal results. So as you'd expect, SHGB has been added to the hormone health category down here. So we can select the report here. You can see an individual's result. So mine is marginally higher genetic score, which I was very surprised about.
Stop showing off. This is the only reason you've done this, isn't it?
Yeah. I could have used anyone's results, but I finally got to have a beneficial genetic result, which is quite rare for me. My results are usually very, very average. But then, we can see within here the recommendations, some of which Stu's already touched upon it, in terms of looking at things like sleep and that type of thing. So
EPA as well. So that's one thing I've just noticed on the was it bisphenol A, which is plastic tubs. There's a lot of evidence that shows that actually that can significantly impact your testosterone level. So stripping out all those plastic tubs, look for BPA stuff, eliminate it as well. So that's something I've just noticed on there. So just as a point to mention.
Well, yeah, because I was going to ask about the interaction between other sex hormones and visceral fat, and then I just thought we just don't have time to go down that rabbit hole. So maybe that's something we can talk about another time.
Yeah.
But just in terms of actually sort of where this is accessible via the portal underneath hormone health. But what we've done is I've also applied, and hopefully you can still see these pop-up windows. But I have added this report to things like the personal training template. So that's actually been added in here as an additional report. I'll scroll past it. In here somewhere. SHBG and bioavailable testosterone, there you go. So that's part of now that 22 sort of page report, which we've pulled together for professionals to use with clients who are very much looking to improve their training response, whether that's resistance training, whether that's aerobic training, optimize hormone health, that type of thing. So as you use these templates and filters, it's been added in there, but it has also been added to the hormone health one as well, which you can find through that template builder. If you do have multiple clients within your account, which I know a lot of our partners do, you can also use the Traits Explorer to see where your clients fall between the different bands. So within this account, I think we currently have 5 members in here. So four of the members in here have average genetic score, and then mine is marginally high genetic score. So you can actually see where your individual clients fall between the different bands on a report basis. So yeah, you can see here, these are all the different bands and how they're split between the total FitnessGenes population. And on the right-hand side, we have the cohort within your personal account. So again, 4 people with average, 1 myself with marginally higher. I expected very, very marginally as well. So yeah, so as I say, for partners who are already using the product, all of your clients, well, all of your male clients will now have, you'll be able to generate the report for those clients. So whether you want to include those in templates or whether you want to send that out as a standalone report, if you find they've got average levels and actually there's some actions that they can take, those are very much accessible through your portal. For anyone who's sort of joined, who's not currently using the professional platform, when you receive your personal results or when you start receiving your client results, that report will be included. And as with all of the reports, we don't put any sort of restrictions or limitations on the information that you receive. So that will be included with all of the other reports relating to brain health and muscle building and weight loss and inflammation and everything else that we deliver. So Stu, I mean, just as a final point, this was the last report release of the year. Is there anything sort of exciting coming up in 2025 that you can share with us that we can look forward to for the new year?
You're expecting me to be able to see into next year at the moment, so yeah. We'll always be putting new stuff out, as we said. Fatty alcohol liver, non-alcoholic fatty liver disease. Sorry, there'll be more on hormone health. But one of the big key things we're looking at as well is actually the organisation of reports. So if you think about, you've just seen on hormone health, you've got cortisol there. Now cortisol will be impacting testosterone in itself. For females, we've got to build up the female components of it. So what would be really good, we've talked about IGF-1 and testosterone in combination there. We've got those independent traits. What we're really looking to build within the system is your ability to go, okay, well, what out of this 180 traits, sorry, are the most important for my client? Are there any that synergistically sit together? And that, for example, if you've got high risk in 3 independent ones, does that mean anything synergistically to the client? And an ability to actually tease that out and then produce summaries. So we're going to always be releasing new traits. That's kind of what we do. But actually, it's the organisation and the ability to interpret the data. I think that is the next generation of technology that we need to give to our customers, because that then improves a client's productivity. It enables you to search and interpret the data better, and ultimately will enable you to bring on more clients and give them information quicker. So that's something that I've been actually working on for 3 years. So it's quite an extensive biological model that underpins it, but hopefully when we give it to you, it'll be really simplifying the wealth of data that actually we currently have within the FitnessGenes portfolio.
Yeah, and even on top of that, we're also looking at releasing our training course in the new year as well. So making that available to all of our current partners and anyone who comes on board. So that's going to be a course focused on the science of genetics and actually how to kind of read and interpret data and understand kind of like the biological basis of kind of what we do as a company as well. So we'll be sharing more details of that over the coming weeks. But yeah, also just wanted to open it up for any questions that anyone had around the report, the recommendations, or any questions in general about FitnessGenes while we've got Stuart Grice here. So please do feel free to use the chat. Can you see those messages, Stu?
Yes. So
do you mind if I read it out loud so that?
Sorry. I don't do this very often.
It was mentioned this or something similar will be put together for women. How far off does that seem? Most of my clients, male or female, are older or special populations. I'm particularly curious about the women's version for muscle preservation as hormones decline through perimenopause or menopause.
Sure. Yeah. So within muscle build, actually, we have lifestyle and non-lifestyle traits associated with perimenopause and menopause. We've got the bone health ones that are linked to also perimenopause as well, and of course then we'll have we'll start to build out some of the hormone ones with that. So with the majority of the female traits we build now, we generally put them in the context of premenopausal, perimenopausal, and postmenopausal. So that information actually will be brought in, because obviously the biological context of a premenopausal and postmenopausal woman is very different. So we really need to, and actually sometimes that requires us actually to build totally independent models for that. So yes, that'll be something we'll be looking at in the new year, and also it will be very much related to the different life stages.
Because that was one of the categories that we released a couple of months ago, was the women's health category, of which we have 4 reports in there currently. Yes. Some of that data is dependent on lifestyle data that we'll be integrating into the B2B platform in the new year, and as part of a larger project to actually bring in more lifestyle and environmental data to offer greater resolution and refinement in the results that we deliver as well. Very much kind of more women's health stuff to come via the B2B platform very soon.
So Josh said, I have a question about how clients ideally interact with the data.
Okay, so I guess this is a more general question around the delivery of the information. Via the B2B portal, so as I sort of demoed with my own results, the professional very much receives access to the information. So it is through the generation of those templates and of those PDF reports that the clients would actually receive their results and their insights and their recommendations. So the way that we've kind of built the B2B solution is to provide you as a practitioner or professional with complete oversight and control of the client data. So you can go through and you can pick out the reports that you think are relevant, or you can build your own sort of preloaded templates to then pass that information through to the clients. So we've very much provided kind of the tools and functionality to allow you to present the information as your own and determine what kind of information you deem to be relevant for that individual. So the end kind of outcome for the client is that PDF report. Some of our partners will send that via email based on the product that the client's purchased. Some of our partners will actually sort of print that out, bind it, bring the client in for a consultation and go through the content with them. Some of them won't actually provide any content to the individual at all, and instead will just use the reporting and the recommendations as they're refining their own sort of workout, lifestyle, nutrition plans. Very much depends on actually how you want to relay that information, if at all. But we've included that functionality to allow you to customize that as much as possible. Josh, follow-up question. My knowledge is that genes can't change, but biomarkers can. So would I expect clients' blood biomarkers to improve over time? Brackets, if the ideal protocol is used, but the genes to not change. Is that correct, Stuart?
Yeah, the genes, the genes are inherited variation. So it gives you, it will give you a benchmark to what you expect to see. But yeah, when you start to see people improving their lifestyle, you'd hope to see the biomarkers improve. But again, if someone's got a genetically moderate lower levels, you won't be expecting them to go off the chart. You can't be chasing these really high testosterone levels. Actually, what you want to do is just actually maintain it around that point. Now, if someone does have genetically higher levels, you might expect to see those biomarkers move more as they improve. So it will give you kind of a base point to kind of an expectation point how to interpret the changes. And this is the one thing you see with a lot of these biomarkers is people don't sometimes see improvements and they get quite disappointed, and actually the reality is they're probably just where their biology naturally sits in terms of the levels of these proteins, and actually sometimes then driving it higher and higher may actually not necessarily be a positive action, because of course a lot of these growth factors do have broader implications for chronic health issues in the future.
And I guess in terms of our own reporting, that kind of movable piece is the lifestyle data. So actually sort of even within FitnessGenes, as a client's data sort of evolves over time, if they sort of gain weight or lose weight or become more active or less active, then actually the reporting within our own system will change, as will kind of the insights and the recommendations.
That's a very good point, yeah. The traits do change. So if you put, and we're putting more and more lifestyle data, including blood data, actually into so it exists within the B2C at the moment. So it's been built into the B2B. So actually you can build. So say for example, you've got a testosterone trait and also the lifestyle, and if someone stops smoking, they lose weight and not going to get any younger, but and also improve their diet, the recommendations and the result will change in the system based on that environmental component. So there is the results will change. Obviously, the core genetics won't change, but the result will change because what we do is model. We model the genetic environmental interaction.
Great.
Cool. Yeah. So it's a surrogate for epigenetics in a nutshell.
Okay. Unless there's any sort of final questions, I think that's.
So one on epigenetics. So we've looked at these epigenetic arrays, and there's something we're always so the ideal position would be you do a genetic test, then you'd have this epigenetic analysis that is ongoing. You can see a lot of these changes. The epigenetic arrays at the moment are probably where genetic testing was 25 years ago. So we were looking at one to actually put in the testing suite, but it was highlighted to us that when people started exercising, you don't see a change in the epigenetic signal, which for a fitness company was non-ideal. And a lot of actually the signal in these, these kind of arrays that are associated with biological age, for example, a lot of the signals associated with CPG islands that are linked to whether you've smoked before. So when you look at a big population, of course, when you stop smoking, you see these switch in the CPG islands and then they change to a older to a younger biological state. But for just the general population, particularly with smoking is becoming less and less, actually it didn't have any real sort of meat on the bones for us to actually have something to show proper changes on a chromosomal level, and that's why we haven't done it yet. It's something we're talking to a UK company and a US company, and we're evaluating it every 6 months, and when we're confident that it actually will show. And again, if you've got a client, the last thing you want to do is this client to bust a gut, change their diet, exercise, better sleep, stop drinking, stop smoking. At the end of it, you do another epigenetic array and it's like 0.5 years change because the signal of all the activities they've done is not read through that particular epigenetic array. So yeah, that's where we're at the moment. If as soon as the quality's there, there's both a business case and a scientific case for us to be putting these things in, because we can see how it's a very beneficial process to be looking at.
And then, sorry, another one from Josh. You spoke about the interaction between blood work and gene testing. What about the interplay between gene testing and stool testing?
I think it's the same answer with epigenetics. It's very interesting. Stool testing currently is quite descriptive. In terms of you list the bacteria that you have in your guts, but there are billions of bacterial species of which there are only a handful that are looked at, and the majority of these gut microbiome tests. There is a lot of diversity that's driven, so if you're a carnivore versus a vegan, that's going to have a huge impact on your gut microbiome, for example. Generally, the rule of thumb is just to improve your gut microbiome at the moment for us, particularly with people who are overweight or may have autoimmune conditions. And that's kind of general advice. So we did exactly the same thing where, I could sell you an epigenetic test and a gut microbiome test tomorrow. I just don't know how it would then, in the way we described how the genetics adjusted our predictions around the blood data, I couldn't do that with the epigenetic and blood the stool testing at the moment. Now, I'm not saying that's not going to be the case in 6, 12 months, 2 years. And when it does change, we will be integrating. We've actually got a patent on our biological model, and it includes blood testing, epigenetic testing, and gut microbiome, and many other microbiomes, actually. And we will slowly build those products into the suite. Again, a business case, there's a lot of people doing it at the moment because it's just something else you can sell. So I can see how it's an important business. There's a business case there. Scientifically, I'm only going to put it in the model when I get a differential outcome by knowing the information. Sorry, I hope that's a bit long-winded, Josh, but I hope that helps.
Yeah, and I think that's an interesting point about sort of epigenetic testing and sort of this ability to kind of continually sort of sell tests. We've very much operated on a single test continuous delivery model for as sort of people like Courtney will know, for the last few years. And I think, yeah, that does concern me. If the value of the retesting isn't quite there, then it does get quite expensive for the end user. And as you say, sort of, if it's not making a material difference or showing significant difference when they're making those changes, then it could be disheartening as well. So, but yeah, Stu, thank you very much for your time, and also thank you to everyone for your questions as well. This is, as I said at the start, this is something that we're looking to do more in the new year, whether sort of with partners or whether it's sort of direct to consumer customers as well. So any feedback that you have, any sort of like topics that you'd like to get Stu's takes on as well, then please do feel free to kind of drop me an email, and we can see what we can look to get scheduled in the new year. But we sound particularly busy at the moment, Stu, so hopefully you haven't got too much holiday booked off over Christmas.
Yeah, I'll try my hardest not to leave the lab.
Yeah, good. Glad to hear it. So yeah, thank you everyone for joining. Any follow-up questions you have, then do feel free to send them my way, and I can pass them through to Stuart as well if I'm not able to answer them myself. But we look forward to you joining us for the next one, hopefully in the new year as well. And thanks for your time, Stuart, as well.
Cheers. No, cheers. And thanks, guys. Thanks for coming along.
Cheers.